Hey guys, today I wanted to show you how you can do a chi-squared goodness of fit test in your calculator. So what you're going to need when you are doing a problem in order to use the calculator is this information right here. You need both the observed and this time we need the expected values as well. So in my calculator, in order to do this type of problem, the first thing I need to do is put these two lists of data into the lists in the calculator. So I'm going to go to the lists. If I go to Stat, Edit, that'll allow me to edit my lists. And I'm just going to use L1 and L2. So I'm going to put in my data first for observed in L1. And then the other in L2. As I'm putting this in, it's really important that you make sure that your lists match each other. So like I put brown first, I need to put brown first again, and so on and so on. So you have to make sure that they're in the same order. So I'm going to finish putting this data in here. As I'm doing it, remember the chi-squared goodness of fit test is the one we use for a one variable, one sample test, where we are testing our sample against a claimed distribution. All right, so now I'm ready to do the test. I'm going to get out of here, and I'm going to hit the Stat button and go over to Tests. And then you could go down, or really it's easier to go up to letter D, chi-squared goodness of fit test. Hit enter. I have my observed values in L1, expected in L2, and I need to fill in degrees of freedom. So remember, for degrees of freedom for these problems, it is going to be the number of categories minus 1. So we have 6 colors, so 6 minus 1 is 5. That is my degrees of freedom. So I'm going to put 5 in here, and I'm going to go down to calculate, and there we go. We have our chi-squared value, which is, if you remember, the same one that we had found in class together, 25.69. And then it also gives us our p-value. So right away, I already know the p-value, so I'll just fill that in on this page right here, 0.000103. I'll round to that many because I like to have at least 2 digits, right? The other zeros, they're all placeholders, so 2 digits are good. And while we're doing this, we might as well just go over some of the state plan do conclude for this problem as well. That way you are reminded of how we do these types of problems. So we've got our hypotheses, the null hypothesis being that the claimed distribution of M&M color is true. And then the alternative, of course, is that that claimed distribution is not true. Remember, I'm just going to use these for sake of time, but don't use the ditto marks on your test. All right, here is the name of our test, which we can simplify to chi-squared GOF test, goodness of fit. And we check our condition. So it says that it is a random sample of M&Ms. The 10% condition, 461, is less than 10% of all M&Ms. And then for large counts, we are testing all expected values are greater than 5. And in order to prove this, we must show the lowest at least. You could show all of them, but it will suffice to just show the lowest. So 59.93 is greater than 5. For the picture, remember that it is a right-skewed graph. We label where our chi-squared value is, always somewhere to the right. We label, or we shade, and then we label our chi-squared graph as the chi-squared with degrees of freedom. And remember to label that it starts as 0 as well. They always do, but you need to label it. We've got our specific formula, which is on your formula sheet. So if you do forget it, it is a fairly easy one to remember. But of course, if you forget it, it's there. And then for work, I'm going to show at least the first few. So chi-squared is the first observed minus expected over the expected plus the second one over the expected plus all the way to the end, so 66 minus 59.93 squared over 59.93. And that's enough to show all of the work. Our test statistic, as we had found before from the calculator, chi-squared is 25.69, and the p-value is 0.000103. So as I conclude, based on this p-value, that p-value is much smaller than our significance level, which we could list here. We should have listed here is 0.05. And so I can write a conclusion. The conclusion has two parts, could potentially have three. The first part being interpretation of the p-value. And so when I interpret p, that is assuming the null is true, there is a 0.000103 probability of getting, and now this part is a little bit different. We do not have a p-hat or an x-bar, so we actually just list our test statistic. So it's of getting a chi-squared of 25.69 or greater purely by chance. Then we can make our final decision. So because 0.000103 is less than 0.05, we reject the null. We have convincing evidence that the claimed color distribution is not true. After this, because we have decided to reject the null, meaning that we had statistically significant evidence, we would do the follow-up analysis. So if you missed this in class, a follow-up analysis is where we state which category had the largest impact on our chi-squared value. And actually, we did this, I want to say that we did this on Tuesday's video, but maybe not. But looking at the table from Tuesday's activity, if I look here, I can see which one had the largest impact on chi-squared. So looking at this table here, which one gave us the biggest value? That was this one, which is the blue M&Ms. So blue M&Ms had the highest impact on chi-squared, and therefore that's what we list in our follow-up activity. So what I say is that blue M&Ms were 36.64 less than expected. Just stating that, they were the largest contributor and by how much. So what that difference was.